Hello world, welcome to episode 4 of our Monorepo series. Today we'll continue from where we stopped last time. And last time we set up pants, we answered the question as to what pants build is, or pants for short. We installed pants, we set up a mini project in Python, and we set up virtual environment, we set up some tasks, we tested this project, we also configured pants, we did formatting, we configured linting, configured security check. We also showed the benefit of pants. And if you don't know what pants is or what monorepos are, check out my previous video. I went into details with this. This is a series that will extend for quite some time. We'll continue building episode upon episode. So if you want to, keep getting your updates, kindly subscribe, hit the like button below. Today, we'll cover a few things. One of them is we'll cover testing, how do we use pants to test, and I'll go through writing the test. We'll run the test and then we'll see how the cache works with pants or pants build. In the video, you'll hear me say pants instead of pants build. I think it's just much easier to say, just it sounds cool. And also we'll set up Docker. If you don't know what Docker is Docker is just think of it as a box where you throw all your application in, and also you throw, all the dependencies you need for your application to run. So the operating system that is required, and just all the dependencies you need, and in a way it's somewhat isolated. This video doesn't go deep into what Docker is. Subsequent video I'll talk about what Docker is and how Docker really works. So we'll add Docker support, write a Dockerfile, Dockerfile, if I know how to spell. Write a Dockerfile, build a Docker image, we'll run the image, and that's what we'll cover for this video. Subsequent videos we'll tag, we'll push the image, and we'll deploy, we'll set up CI/CD. So let's get started today. So I'll save this first and come back to my repo. And I already have this opened from last time. If you remember where we stopped, last time we just set up all the files that we need to do to run the project, and also to set up pants build. Today we'll continue from there. We'll add more things to this, like I showed in the README. We'll add the test, run the test, and then we'll add Docker support. So first things first is let's come to our toml file. This file contains everything that we need to configure for Docker, right? So we need to add tests. So first of all, let's go through our code and explain all the tests that we already have, because we already have Python support here, so we're good to go for everything Python. So I already have a file here. I have some files here. This is a model file, and this model file just tests my model from last video that we created. It just sets up an in-memory database, the engine, the session, and then it creates a fixture here. Now, if you don't know how Pytest works, this video really doesn't cover how Pytest works. I'll have subsequent videos to talk about how to set up Pytest and how Pytest works. Well, at a high level, this is just a fixture. And what a fixture is something that does your setup and also your tear down. So say for instance, I need to write a function and I need to do, some setup, like set up my database to be able to test the function, or maybe just create a folder or file to test the function. That's where this comes in. So this is a fixture that sets up the database for me. Pretty straightforward logic here. Also, I have my model here that tests the task. I think I'll put this side by side. I think it's much easier to really see what's going on. So let's open the model here, close this and close this. So I think this is much easier to read. So we have our task model, which pretty much tries to test this class to see if this class works. And now In most enterprise world or enterprise, organizations, you most likely wouldn't test this class, right? Because this is just a data structure class, right? But again, this is just for explanation, right? So I have my test. I set up. Just drag this and drag this guy down. Drag this a little bit. Okay, so that looks better. So I set this up, just passing variables, random variables, add it to the database, commit, and refresh. Pretty standard stuff. Then I just assert the result. I test the to dictionary to see if it works. And this is the test model for this, right? This just all this does is just to test this entire structure to see if it works. Pretty straightforward test. And then I also have my router, which contains more details. So I'll just open the router here. I'll put the GitHub link in the description below if you want to see the entire code base. I'll put the GitHub link in the description below. So I have my router here, and my router, again, pretty standard stuff, just a post endpoint, and I have a fixture here that does the cleanup, cleans up this database, that writes to the directory since this is a local database. I have a helper function here that just mocks my create task. This just allows me to be able to mock this function. If you don't know what mocking is, again, I have a great article that actually goes in details about mocking and Pytest. I'll put a link in the description below and probably also do a video on how Pytest works. And then we have this add task, which is this post we want to test. We set up all the mocks that we need, and we call our mock function here, and we do a post to that endpoint, passing the parameters that we need. We assert that the HTTP code is correct. We also assert the JSON response. Pretty standard stuff. We apply the same thing for our get task, for our edit task, and for our delete task. And then we also have a health endpoint just to test to see if we can hit the health endpoint. All of this pretty straightforward stuff. We're just trying to test our code. Usually this is standard practice. You write your code, you have your test. You test if your code works before you get your code to production. Great. So now let's come to pants. This is really the focus of the video, to show the benefit of pants and some of the commands that pants has to offer. So first things first is I'll close this and I'll come back to my terminal file here. And now we already have Python set up, so we can run this to see how this works, right? How we can test with pants. So first of all, I want to test, I'll just clear this guy. So first of all, I want to test this with Pytest to see if it works, just to show that it actually works. And to do that, I have my VS Code settings here. If you come to settings.json, I have a settings here that tell my Pytest plugin where Pytest is, where my test folder is installed, right? And this just says, oh, this is where the location of all your tests are, right? So if you go to the folder source Python, you'll see that I have a folder here. It's like source Python and then test. That's where I store all the tests, right? So that's good. So we can run this. So we have to cd into source to run this, or maybe we can run Pytest from here. I'm not sure, but let's try this. Pytest. Oh, we get some error. So we have to cd into the Python directory. Now the reason we get this error is Python or Pytest doesn't know where our root directory is, right? We have a pytest ini.ini file here. Inside the pytest.ini file, we specify where our root directory is. And for simplicity, I store this file inside the Python folder. So if you go to pytest.ini, you'll see that I'm saying that this directory is the root and this is the folder. So right, so from this Python directory, which I'm in, source Python, I'm inside Python, I'm saying everything here inside this Python, that's what this dot signifies. Everything here inside this Python is my Python path, right? That's where I'm saying that my source code lives. And then I say my test is everything inside this test folder. That's what I'm referring to my test. Right. I think this is just much cleaner, to have like Python related stuff inside a Python directory. I think it's just much cleaner. So I have that there. Again, you can put this anywhere, but I just think it's much cleaner to have inside a Python directory. So because I have it inside this Python directory, I have to go inside a Python directory to run Pytest. And when you look at this project eventually is going to have multiple languages, right? So there's no point having like the Pytest at the root level since this will have multiple languages. So I'm going to cd into the source Python, and then I will run my Pytest from there. So let's do that. So I'll clear this first, and then cd into source Python, and let's clear this to make it cleaner. Then I'll run my Pytest from this directory. So I'll say Pytest run. Good. So all my tests pass, which is great. See, all my tests pass now. So I can clear this. And since all my tests passed, I can also run this from my VS Code. So if you have the VS Code extension installed, if you have Python installed in VS Code, usually it comes with testing, and you can configure this based on these settings that I showed earlier, right? This settings.json, it will configure it, and we say use Pytest, don't use unit test. Unit test is just another testing framework in Python. So we can come to this test, and from here we literally can run all our tests, and again we see that all our tests pass, which is great. So we know that this is working with Pytest, right? This works with Pytest. Now, where does the benefit of pants comes? Benefit of pants comes with the fact that it has caching, right? So it only runs the test on what has changed, which is awesome. It can speed up your pipelines. And also, it runs a test on like transitive dependency. So you have something related to something else. If that thing changes, it runs the other thing that is dependent on it, right? It just runs the test, which is very, very awesome. So let's set up pans for our test. And the first thing we need is we already have our test written out. We need to create a build file, right? I already created this file, but I'll just delete this for ease. So let's assume we just have our test. So now let's go one level up. You literally can run this from anywhere, but just for simplicity. So let's go one level up, rather 2 levels up. So we'll clear this, and then we run pants and tailor everything. And what this command means is it will create all the build files that you need based on your files that you have here. So like how we created the build files for requirement, we'll also create a build file for our test. And this other command here just signify tailor everything. So it's going to go through and see what are the new files you've created and create a build file relating to that. So run that. Good. So we see that I created this build file. See the location of the build file. It added test, Python test, and it added a new target called test. So if I go to that file, and this is the file, we see the file has been created, added a target. The target tells you what you want to run in pounds. It added a new target called test, right, which is awesome. So if I want to run my test, the way I run my test is I can say pants test everything. So this will test everything. Good. So now we'll see a few things. Now, the way Panth works is Panth understands all your dependencies, and Panth will go through and say, what is dependent on what, right? And once Panth goes through to say what's dependent on what, that's how it's able to bundle everything in a sandbox and run your test, which is great. So you don't have like unnecessary dependencies. This error tells us that this module HTTPX is not found. And if you drill down into this error, you'll see a few things. You'll see that it's saying that it can't find this HTTPX. One of the tests, passes already this test module. And you'll see the runtime error Starlink test client module requires HTTPX package to be installed. Right, so if I go to this test that is failing, and it tells us the test that is failing, this test router. If I come here, I'm able to see what it's saying. It says this test client, which is this, requires HTTPX. Remember I say that the way Pant works is it works in a sandbox environment. It pulls everything that you need into this sandbox and then run everything. That will ensure that you always have the same result, irrespective of the environment you're in, every time you get the same result. So this is saying that this is not able to see this in that sandbox environment. And the reason why is this is not specified anywhere. Pant will only include all of this that is specified by itself automatically. You don't have to write it out. It just looks at your import statement and then knows how to build that sandbox. Or you see, it's lacking my import statement, right? It's lacking this, and that's why it's failing. But yeah, it's actually passing. So we have two ways to fix this. A hacky way will just be to import HTTPX, because this was already installed with Fast API test client. So you could just import HTTPX. That's one way to do this. So let's run this again. I'll just clear this and then run this again. Good. So we see that our entire test now runs and pass. But this is not good. This is bad code practice because we are not using this dependency, right? We're just putting it here so that Pant knows to include this into the sandbox environment. So a better way to do this is to use Pant dependencies to tell Pant how the dependencies really work. So we'll come to our build here and we'll add that dependency to say, okay, this dependency is required despite we didn't write it out in our import statement. So we'll say dependencies is equal to, then we specify where this dependency lives. This dependency lives in our third party and it lives in our requirement. So if we come to our requirement here, we'll see this dependency, right? So it lives in our third party. So we'll add that. So we'll say third party, then we'll say Python, then we'll specify what the name of this build is, because we specify the folder, then we specify the name of this build, requirements, and then we specify what file or what import we actually need, which is this one. So we can just copy here and then we paste it there. Good. So now Pant knows that when it's building your test sandbox, it would also import this HTTPX. Despite you didn't explicitly write it out, you're telling Pants that, hey, I still need this in my sandbox environment. So now let's run our test. I think I might have an error when I was writing this. So let's see if I can spell dependencies. Okay. So let's run this again. So we have third party, again, some minor errors here. Third party Python requirement HTTPX. So that looks correct this time. So let's run this and boom, our test passed. This is great. So next thing is, let's try to simulate a test that we change the file and then just run this. So you see it's cached, everything is cached. So that's why this is very fast. So let's change a file. Let's say I change this test, just for ease. Then I run this again. Good. So we see that this test I didn't change was actually memoized. It just means it pulled the data from cache. And then this was rerun. So essentially, this is the only test that we ran, which you'll be able to get some good performance boost if you're running long running tests in your CI pipeline. Okay, let's take this one step further. Let's say I change some things that are dependent on other things, right? So this task, for instance, is used by multiple things, right? This task is used by my router. Yeah, my router does a create task, and it's used by my service here. So it's used by lots of things. Yeah, right. So because of that, let's see if I change this task, which is used by multiple things. Let's see how our test will respond. So let's just change this. Let's just add some dummy content. Good. Now we'll see that our entire test ran, and that's because this task file is used by this service, and the service here is used by this router, and this router is used by our test, right? So it's able to see what's dependent on what and then run your test on that entire tree. And think about how important this is when you have like long running tests in your CI pipeline and you have multiple changes going on in that CI pipeline. Sometimes you have to rerun the entire test, right? Most of the time. And in this case, you don't have to. It just knows what has changed, and based on that, it runs that specific test. And I think this is a very, very important feature of PANS. So let's update our to do. So come to README, yeah, and we'll update that. So I just have this. I guess I didn't do proper cleanup in my test. I'll just delete it. It's not really necessary. So come back to our README and we'll say we've done this. We've done this. We also run the cache, tested the cache to see if it works. Now we'll add Docker support to this. And to add Docker support, there are a few things we need to do. One of them is we need to tell Pants to include the Docker plugin. And also we need to make sure that we have Docker installed. Now, I didn't go through how to install Docker in this video. There are other materials on how to install Docker. If you need a video on this, just post it in the comment section below and I'll create a video on how Docker works. So let's first of all set up pants to be able to add Docker support. So come to our pants.toml here, and we'll jump back to the README and just show how Docker support works. So go back to the README and go to docs, and we'll go to Docker. So see that this uses a PEX file, right? A PEX file is similar to a wheel file. Now, if you don't know what a wheel file is just how you bundle your Python package together, and then you distribute it, you deploy it, or you distribute it, right? Usually in Python Docker, you have to copy the entire file, right, into your Docker image. It's not a single file you copy. The problem with that is it's somewhat loose. You don't even know what Python interpreter that wheel file works with, right? You don't know the Python interpreter, you don't know the target environment that wheel file works with, right? So, and it's multiple files that you have to move around. With PEX is just a single file. PEX is one file, bundle everything together. It knows what target environment you need, and also it knows the Python interpreter that you're working with, the version of the Python interpreter you're working with. So it's one file that you just copy around. So Pants makes use of that, which I think is much easier to work with. So first things first is we need to add Docker support, and this is how you tell Pants to include Docker support. So we'll copy this, and then we'll go back to our VS Code. Okay, so we'll add Pants support. Oh, so just for consistency, I'll use a single quote. Doesn't make any difference, just for consistency. So I have my Docker desktop here. I just make this bigger. I have my Docker desktop here. I have containers, I have builds, just regular stuff about Docker desktop and how it works. Okay. So again, if you don't know what Docker is, just think of it as a box. You throw your entire application and dependencies into it, right? So we need to add a few things. We need to tell Pants where our Docker is installed, our Docker CLI is installed. And the way you do that is you can do Docker. Now that we've added this, you can do Docker, and you can tell it where it's installed. So you can say, and this is not compulsory. Sometimes this works without you telling it where it's installed. Sometimes it doesn't. Just in case you're having any error, you can tell it where it's installed. You can say env. And this is also in the documentation. Let's go to the documentation. I think it's much better that way. So scroll down. You can just copy this, and this is saying my Docker authentication code is located in my home directory .docker, just in case you have any authentication issue. For me, I didn't have that problem, right? So this is just, while you're going through this video, you have that issue, you could also put it in your toml file, or put the link in the description below. I'll provide the help I can. So back to our video. So you can add that there if you want. For me, I didn't need to add that, so I'll just leave that. The other thing is you need to sign into Docker, right? This will allow you to be able to pull down images and push images to Docker Hub. So you need to create a Docker Hub account and sign in to Docker. If you don't know how to create a Docker Hub account, pretty straightforward. Just go to Google and do Docker Hub, and you can come to the account and you can sign up here. Pretty straightforward. You'll be able to push your Docker images to this place, and you can pull your Docker images down. So we need to sign into to Docker Hub, right? So the way to do that from here is you can come to your client here and just clear it. And you could do Docker login from here. This is one way. And because I already logged in, it just did the authentication automatically. Or you could go to your Docker desktop and click this link here, because I already logged in. If I was not logged in, you'll see login here or sign in, and then you can click that link and you'll be good to go. So just log in into Docker using the methods I mentioned. So once you're logged in, Docker needs to know how your configuration is stored, how your configuration keys are protected within your system. In Windows, Windows uses WinCred, and in Linux, I think you use something else. In Mac, you use the Mac keychain. This is just how your credentials being protected within your system. So in Mac, it's different. So this is how you actually access it in Mac. Code, and then so this in Windows, this will be your user directory, right? So you could do code, and you could do / I think it's called Docker, and then config.json. So all we're just trying to do is open this config file in our VS Code so we can look at how this config file looks like. Great. So when you open this config file, what you see here is we see the keychain. This is what's being used to store this, right? OSX keychain. That's a credential store. Again, on Windows, it will be different. So whatever you have here, that's what you have to put in your pants to let pants know that that's what we use to be able to access Docker. So I'll come here. In the Docker, the credential is this guy. Cool. So now we have this. Let's create a Docker file. Okay. So let's create our Docker file. So we'll go to, so if we go to our documentation earlier, we'll see that Docker uses packs. Now this is Docker with pants. When you build in your Docker images with pants, it uses what's called a PEX file. A PEX file is similar to a wheel file, but it has more benefits. The problem with a wheel file is there's multiple files, and these are loose files, right? It doesn't contain like any information that tells you the target environment you're building for. It doesn't tell you the Python interpreter version that is required. So it lacks all this information. So Pants uses PEX files, and I'll show how to build these PEX files shortly. We already did this, and I'll show how to build the PEX files shortly. So let's build the PEX files first, then we'll come back to adding our Docker support. And we'll show us how to add a PEX support. So if you run package, is going to create a PEX against anything that requires a PEX. So just scroll down and we'll see how you add a PEX support. So I can copy this and let's go to our code. So come to our task API. Yeah, build, and we'll add a PEX support. So now we have PEX, and let's just call this task API, and let's call it PEX, just for simplicity. So now we have this. So let's run package so that you can build these packs, and then we'll see where this packs was built to. Good. So now we'll see this is the PEX file that was created. One single file instead of a wheel where you have multiple files. Let's try to run this PEX file and see if it runs. Good. So we see that the PEX file runs. And this is really, really good because it built the PEX file, one single file, and it built it for my system. So there's this idea called a platform where you have to tell PEX what build is it building it to, right? You could build to multiple platforms because when you're talking about Docker, usually maybe you're working on a Windows, but your Docker container is a Linux container, or you're working on Mac OS, and the Docker container is a Linux container, right? So you have to tell it to build to that specific platform that you want to work with. That's where the idea of platforms comes in when you talk about PEX. So you tell it build to this specific platform and use this version of Python as well. So we'll tell this to build a specific version of Python as well as use a specific Linux platform or Linux environment. I'll show you that in a moment. Yeah. So clear this, and let's go to our Docker environment. I'll close this. Let's go to our Docker desktop and set up a few things there. So first things first is we come to our Docker desktop. So if you have Docker desktop installed, you will have something similar to this. This is a more recent version, some slight changes here and there, but pretty much the same thing. So first things first, ensure you're signed into Docker desktop. There'll be a sign in button here. Create an account if you don't have one. And the sign in button will be here. You can sign into Docker desktop. Right, so once you sign into Docker desktop, either using this button that'll be here, or you can also use your terminal. Yeah, so you could do Docker login, and I already signed in, so this didn't make any difference. So once you sign into Docker desktop, we have to try to figure out what platform does that Docker environment uses, right? So we have to figure out what platform it uses. Okay, and to build our Docker image, we want to use Python 3.10. So I want to use this version. I think this version is a lot more stable, and that's what we've been working with. So we use this version for our Docker environment, and we use a smaller image file, right? So let's use that version first, create the Dockerfile, and then we'll add the platform I was talking about earlier. So let's come here and create a Dockerfile. So say Dockerfile, and I will say we'll specify Python 3.10, and I want to use the slim version of this, right? This is just a smaller image, so it saves you space, saves you time when you're pushing and pulling the images, and also it has smaller security footprint, so it's just relatively safer. Then the next thing is I want to specify the workspace. So I'll say workspace, or work directory rather. I'll say /app. This will just tell us where we need to store the files. Any file that we're working with, this is where we store it, this is where we start from. And then I'll copy the PEX. Remember this PEX that we created. So I'll copy this. I'll copy this. Copy from this. Now you have to specify the full path. You see the full path here, so I can copy that. So Pants will have access to this directory. Copy this and copy this specific file. It's kind of weird calling it pex.pex. So we'll just leave it. You can actually call it any name you want. And then I'll copy it into app.pex. So inside my Docker image or my Docker container, this will be the name. Then we'll set the entry point. The entry point is just the executable you want to run or the command you want to run. And the command I want to run is just this file. So that will run that file. Great. So now we have our Docker image all set up, which is good. We can build our Docker image, but we need one more thing. Remember I was saying that Pex needs to know the target environment. In this case, this was built for my Mac. And just imagine you're running this in a Docker environment that is a Linux container, right? You have to tell Pex or you have to tell Pant that I need you to build this Pex file for that specific target environment, right? Else it won't work. You build this for your Mac and then you move it to your Docker container and everything's going to break. So you have to tell it that it needs to build to that specific target container. And the way we figure out what target container or what target that this is pretty straightforward. So first things first is we need to run this Docker container, exec into this Docker container that is just this Python image and see how that works, right? See what's inside. And then we can install Pex and then we can extract the platform from it. So I'll just clear this and I'll say docker run --rm -it interactive run this Python image 3.10 run slim and then run the bash command. So this is going to exec into this, is going to run this in interactive mode and run bash into on this Docker container. Good. So now we're inside this Docker container, which is running, which pretty much is this Python image, nothing inside yet. So let's install Pex. So the way we install Pex is this. So pip install Pex. So we can now run the inspect. And the way to run this is to say Pex 3 interpreter inspect markers tags, then just indent to 2. And let's see this. Good. So this will tell us the platform details specific to this Docker container. All right, so this is a Linux environment, entirely different from my local development environment. And we can now use this to say build your Pex file just for this, right? And we can copy this. So we'll just copy this entire thing. So we'll copy and that will create a folder inside this Python here, inside this Python directory. So I'll minimize this. Inside source Python, I'll create a folder here and I'll call it complete platforms. So this will contain pretty much this file. And inside there, I'll create a file called Python 3.10 complete platforms.json. So complete platform.json, and then I'll just paste what I copied. So this is the platform details. It will know how to build a PEX file to this platform. So let's clear this, and you can quit this, or I think exit. Good. So we have this file that tells us the platform you want to build your PEX to. So we can close this, and we need to tell Pant that we have a new file that we have created. So Pant knows that we have a new file that has been created, and Pant is able to create a build file for that. So we'll say Pant Taylor, and then it will create. It created the Docker image, and so if you come here, I think you'll see the Docker image that it created. But for some weird reason, it didn't create this. So we'll just create that manually. We'll come here, and then we'll do build, and we'll say this is a file, and the file has a name, and the name of the file, I'm just giving it the target name. So 3.10. This is just how we'll be able to call this, right? Underscore slim, and the source file is this file. So just so we say this is the source file, this is a target. So we added this to the Pant build system. So Pant knows the target, that this is also a target, and we can consume this, right? So the next thing is we need to tell our builder our PEX file here to use this target to be able to build the PEX, right? And the way to do that is we just add a platform here. So we add complete underscore platforms, and then we specify where that lives. So it says in the source, it's in the Python, and this is called complete underscore platforms Python underscore slim. So this was the name we gave it. If we come back to this was the name we gave it. I can just copy that name just so we don't have any typos. And we specify the source folder, and this is good. So this is good. Now, if you don't add this, you'll notice an error. Okay, so I'll just comment this for the time being and kind of show you the error you get if you don't add this. So say Pants package everything. Okay, it's able to build the Docker image, which is good. Let's try to run this without the Docker image. Okay, with the Docker image rather. So say Pants run source Python task, and we can say Dockerfile. Great. Now this is the error I was talking about. If you look at this error, it's saying fail to find compatible interpreter. So it doesn't know what interpreter to build the PEX file for, right? This PEX we're building, what interpreter does it use inside this Docker image? It doesn't know. And you also see this error. It's saying SQL alchemy could not be resolved for this version of Python, right? And it's saying that the only version it sees is this, and this platform only is a Mac platform. But what we are building to is a Linux platform, because the Docker container is a Linux platform, and it's unable to find this specific library that works with that target environment. So that's why we need to add this line to say, okay, build it based on this complete platform file, and this complete platform file content it contains details for the Linux environment. So that's why we need to add this line here. So I'll just add that and clear my screen, and let's rerun this. Great. So we see that we're able to run this, and this works. All right, this is great. This works. Let's clean a few things up. So first things first is I kind of don't like this name, because this is task API underscore PEX. I'd rather call it binary, just for simplicity. I think it's better. So we'll call this binary, and that means we have to come to our Dockerfile here, and we have to change this name to binary. I think it's much more understandable. And then so that's good. Next thing is the Docker image. This target, it just calls it Docker, right? So you see when it builds the image, it calls it Docker. I don't think that's a good representation. So we can call this task image. I think it's a lot more better, right? So let's run this again. So you see the name is a lot more better now. Or we can even say task API image if that's more explicit. I'll run that again. Great. So see, it has better name now, which is much better. Okay, so now we have our Docker setup, we have our PEX setup, and we can run this in Docker. Let's go through the build distributions here. So we see a few things. We see the PEX that was created, and we see the Docker, the info. It just contains some metadata telling us, what was pulled. Nothing really that important here. And so let's go to our Docker desktop and see the image that was built there. So I'll go to Docker desktop, pull up my Docker desktop, and I'll go to images, and I can just scroll. I'll see a few images that was created because we created multiple. So we'll see that this image was created, right? And if you go through, next video we'll talk about Docker Scout, but not into this video. Well, if you go through, you can see that the PEX, you see the code here I wrote earlier. I copy the PEX work directory and the PEX here. So the reason I didn't add Python here is because Python already starts by default, and then this PEX just runs against that Python. So we can see the Docker image here, which is great. You can see the Docker image here, which is great. So the next thing is, let's run this container see if we can interact with this container, and that will wrap up this video. So let's go and run this container. So go back to my VS Code. I'll just clear this guy. And let's go through our Dockerfile first. So our Dockerfile is good, everything is fine. Go to our main.py. Our main.py, we'll see it's running on port 80, right? And it's running on this IP. So let's talk about port 80 first. So port 80, I just chose a port here. You could choose any port. Usually, most times you choose like 8080, but it doesn't make any difference. I'm just using port 80 here, right? And I have a .env here where I could literally, inject whatever I want here. Doesn't make any difference, but I'm using port 80 here. So that's what I'm using. I'm using port 80 here. And in this place, I'm using 127.0.0.1. And what this means is I'm saying this is the local IP that I want you to run this on, right? And that IP is only accessible within the Docker environment. So if you're within like the Docker container, that's when you can access this, right? So I have to tell this that, hey, I need you to be able to, I need this to be accessible from even outside the Docker container. So that's why I can't use 127.0.0.1 because this is only within the Docker container. So I have to change this to 0.0.0.0. And what this does is this attached to any network interface that you have. So it allows you to be able to connect even from outside the Docker container. Okay, so that's one. The next thing is this port. Inside our Docker container, it's somewhat like a box. We need an external port and an internal port. This application will be running internally on port 80, but you need to be able to access it from outside the Docker container itself so that you can hit the endpoint from my local system to inside the Docker container. So I have to do somewhat a mapping or a direct mapping of ports to map to this port 80. And there are several ways you could do that. You could specify that here. I usually don't like to specify it in my Dockerfile because I think it just becomes hard-coded specifying it here. Or you could specify it inside the Docker command. So let's do that using pants. So I'll say pants run, and then I will say the Docker argument I want to pass, my Docker run argument. So I'll say Docker -- Docker run -args, and then I'll specify the argument, and I want this to run on port 8080. So this is my external port 8080, and this is my internal port. All right, so that's good. Then I'll say what file I want to run. So I still want to run my source Python, my task API, and I want to run my Dockerfile. Okay. So run this. So see the image is built, and then it started running again on the port I specified. So let's go back to our Docker desktop, and we go to containers. So we'll see a container running here. This was just created. You can also give it a name if you want. I didn't give this a name just for simplicity. And you'll see the external port and you'll see the internal port. All right. So now I can test this to see if it works. So let's go back to our VS Code. I think I have Thunder client here. I can do a get request on this. So we'll see that this works. Get request, see the get request here. I can do a post request on this. And good, we're able to post some descriptions And if you watch the previous video, you will understand the task, that this is just a simple task API. And if I go back to my get, I'm able to get the result. So this is really, really good. We're able to show that we can build the image using pants. So I'll just kill this for now. And I know what you're thinking. Why do you need pants to build your Docker image when you already have Docker? Well, pants uses Docker under the hood to build the Docker image, right? It uses Docker under the hood to build the Docker image. And usually it's able to understand your dependencies, right? So like in this case, I didn't say rebuild this. It knows to rebuild this and it knows to copy this, right? So imagine you have like 10 Docker files inside your repo and only one Docker file changed, right? Say for instance, you only changed this. Why would you have to rebuild the entire Docker files, right? That would take time to build, that would take time to run. In this case, you don't have to build the entire Docker files. You just only build what's changed. That's the huge benefit of pants. It understands what has changed and is granular enough to build what has changed and what is dependent on what. So let's go back and update our README. So I'll say this is done. This is done. This is done. This is done. And that will conclude this video. The next video will set up our Docker registry, push this to Docker registry, we'll tag the image, push it to the Docker registry, and subsequent videos will push this to CI/CD, and then we'll start adding other language support. We'll just add Java to show that this is possible. That will conclude this video. Thank you so much for watching. If you love this video, you love the content, please subscribe, hit the like button below. And if you haven't seen the previous videos, the link will be in the description below. Check out the previous videos. Thank you for watching. I'll see you in the next one. Bye.